Now we want to look at two types of data, qualitative data and quantitative data, and the differences between the two. So qualitative data, start there. Qualitative data is the measure, or it's also known as categorical data. So it's data that measures the qualities, data that shows the qualities of something. All right, so we most often use bar graphs. Okay, so a bar graph, or we use a pie chart. And one thing to think about in terms of a pie chart is it's always out of 100%. So we always, when we're talking about qualitative data, we always have all the data represented. So even though we're talking about the federal spending of $4.06 trillion, so that's a numerical amount, it seems like, oh, wait a minute, that would be quantitative because we're counting something, but we are looking at the categories by which that money is going. And so the categories are health, the remainder of it, welfare, defense, and pension. So those are categories by which we are representing, or qualities by which we are representing the federal spending on in terms of the fiscal year 2017. Another way to think about this is a bar graph. Notice that our bars do not touch, and our qualities or our categories are down along the horizontal axes, and the number of things is along the vertical axes. So this is our, in this case, our coffee. So in order to construct a bar graph, because that's generally, so when we're doing the pie chart, we usually use it in terms of percentages. But when we're doing a bar graph, we're always doing it in terms of the number of. And so when we construct a bar graph, this is very similar to when we did probability frequency tables. So your categories or your qualities are in this first column. And then the frequency, so this is the number of items that is happening. So if I look at my bar graph, so I'm actually kind of reverse engineering this because I was given the bar graph, so now I'm creating this frequency table. Normally we do it the other way. So you can see the little numbers at the top. So those are our frequency, and then it adds up to 43.2. The relative frequency, remember a relative is a percentage. So the relative frequency here is just taking this first number is 10 divided by 43.2, and then 8 divided by 43.2, and so on and so forth. And because we're rounding to one decimal place, this won't necessarily always be 100%, although if we round to the nearest whole number, then we do have 100%. The cumulative frequency is to add the previous one, the previous frequency, or previous relative frequency. So the first one is 23.1. This 41.6 is 23.1 plus 18.5. And then 41.6 plus 16.2. So notice that 16.2 is this 16.2, and so on and so forth. This should be 100% again. So actually these two will be 100%. Again, because we're rounding to one decimal place, we're going to be slightly off simply because of our rounding error, which we talked about earlier about rounding errors. All right, so that's how you make a frequency table, so that we can make the bar graph. So we're going to look at this particular example. So let's suppose that this is the grade. So these are just student grades for a particular, maybe it's the course, maybe it is for an exam, whatever it happens to be. And so we have this many grades. So the first thing we want to do is count up how many A's, how many B's, how many C's, how many D's, and how many F's there are. So let's go ahead and do that. And then that will go in our frequency column. And then we'll know how many total number, and you can obviously go through and figure out how many total there are, so you can figure out how many to make sure that this adds up to the number of items that we have here. Okay, now that we figured out how many went in, how many A's we had, how many B's, how many C's, how many D's, how many F's, count them up 40, double check to make sure there's 40 items there. The next thing is the relative frequency. So we're going to take 13 divided by 40 to find out that percentage, and rounding to one decimal place, we end up with 32.5%. 9 divided by 40 is going to give us 22.5%. 8 divided by 40, 7 divided by 40, 3 divided by 40. So 8 divided by 40 is 20%. 7 divided by 40 is 17.5%. Then we have 7.5%. When we add each one of these up, we do in fact this time get 100% exactly. Now for the relative frequency, well, the first one is just the cumulative frequency is just 32.5%. Now for this next one, we're going to have 32.5 plus 22.5, which is going to give us 55%. And then we're going to take 55% plus 20%, which gives us 75%. 75% plus 17.4% is 92.5%. 92.5 plus 7.5 is 100%. So now we need to draw our bar graph. And so along, let's see, I need A, B, C, D, and F. I need those. And then now I need to go all the way up to 13. So I can either count this by ones, I could count this by twos. I'm going to go ahead just because of space. I'm going to count by twos. There's 14. And generally, you'll want to do this either on grid paper or use a straight edge for this. So for our A's, we have 13 of them. And so I'm going to go all the way up to 13. And then for my B's, I have 9 of them. That's about right here. My C's, there's 8 of them. And let's see, D is 7. And then we had 3 F's. And because I'm not using grid paper, it's probably a good idea to go ahead and write these numbers in so that it's clear to the reader what each one of these numbers are, because they don't necessarily will see the frequency table, but they definitely will be able to read the bar graph. Okay, notice your bars, bars do not touch. And they are the same width. So that is one of the ways that we could account for qualitative data, is by using a bar graph. We could make a pie chart using the 32.5%, the 22.5%. So again, this frequency table, so we could actually make a pie chart using this information in this. So we always want to use a frequency table to help us with our qualitative data.